All right. Good afternoon, everyone. I hope you had a great lunch. It's a bit rainy out there, so actually it's a good time to come here and listen to our next guest. That's Gian Marco. He's working for Arm. He's an engineering lead at Arm, and he will talk about how to get mobile AI just faster and what's coming for the developers. I hope you're excited and not too sleepy. Please welcome our guest and speaker, Gian Marco. Oh, we do have some. Are we ready? All right. Welcome, Gian Marco.
Since we are talking about mobile, let's take a selfie all together. Cool. So what a pleasure to be here. So my name is Gian Marco Iodice. I'm the generative AI engineering lead at Arm. I have been working for roughly more than 10 years on designing, optimizing AI libraries for mobile deployment. I co-created the Arm Compute library in the past, and also the most recent KleidiAI that you're going to hear quite a lot today. And also the TinyML cookbook. This just to say that I'm a developer. And this presentation is for developers to know what's happening and what's coming. In particular, for those that are developing AI applications for Android smartphones. So let's kick off with the first slide, a slide about generative AI. Generative AI is not a buzzword. It is something that is happening. As I mentioned at the beginning, I'm going to talk about what's happening to also understand a bit more about what's coming. But generative AI for mobile is a bit different from generative AI in the cloud. Here, we don't rely on internet connectivity. Here, everything runs locally. And most of the time, when we talk about generative AI, we typically refer to large language models or something that can generate text or images, maybe. But actually, today is more than that. It's not just about text. And this slide actually summarizes what we have achieved in the last year on mobile phones. The use case, I really love it, is the group chat summarization. Why I like it? There is so much generative AI there you cannot imagine. I want to give a very simple example. How many of you have a message app, and you are in a group chat, and at the end of the day, you have a group chat with hundreds of unread messages, with images, voice notes, and maybe because they are organizing, they're planning a birthday. But you don't want to listen all the voice notes. You don't want to see all the images. You want to know just what they have agreed upon. And basically, generative AI can help you to understand, for instance, what they have agreed, the type of gift they have agreed, and the discussion, for instance, where they're going to celebrate the birthday. But it's not just about group chat. There are also use cases for something incredible. I love the next use case because actually there is no better place than Berlin to talk about this use case. It is audio gen on mobile phone. So this is a video, hopefully with audio as well. You're going to hear an amazing audio quality generated directly on the mobile phone. I loved, honestly, to host a DJ session today. It's not going to be a DJ session, but probably you heard the quality, the bass, the crease is actually stereophonic. It's 44 kilohertz, simply running on your mobile phone. I also have the smartphone with me in case you want to connect later and discover more about this use case. And you're going to also discover how this actually runs on the Arm CPU. This is a slide where I'm going to summarize the reasons why we should care about AI on the Arm CPU. And there are at least 3 main reasons for that. Scalability. Well, first of all, it's fully programmable. You can imagine all the different data types to deploy your AI applications. AI applications for today and also for tomorrow. Audio generation is just an example. It wasn't a thing a few years ago. It became a thing in May after a very successful collaboration with Stability AI. But the beauty of running on the mobile CPU is that you can also mix different pipelines together. It's not just about AI. Your AI can live in a context where you need also image processing computation, or you need digital signal processing algorithms as well. The other aspect is crucial and unique to Arm. Most of the time, you read, write once, deploy everywhere. For Arm, it's different. Optimize once and deploy everywhere. And in 10 years, this is actually not a marketing statement. This is actually an engineering statement, because this is what I have seen in these 10 years by working at Arm. The optimizations that we have, for instance, deploy for mobile phone, could scale for also in the cloud, okay, on the Arm CPU. And this is very, very unique to Arm. Security is the second aspect, and is about the features that are in the processor that actually make the computation secure. The third aspect is about performance. Great GenAI performance, and you will see a bit more later during the presentation. Here I have reported just a few examples. How long does it take, for instance, to generate 11 seconds of audio? With the technology I'm going to announce today, it roughly takes 2 seconds. And you can imagine, if you're a music producer, this is great. You don't need to search on the website to find the perfect beat or the perfect sample. You can simply text it, prompt it, and you generate different samples every time. Low latency, this is crucial for real-time algorithms in particular, whether they are hard or soft requirements. And why? Because you don't need to offload the computation, right? You can start immediately. And this is actually the beauty, one of the interesting aspects of running on the CPU. But when you talk about Arm, it's not just about the processor. It's the entire community. And this slide summarizes the great aspect of working on an Arm IP. Because when you build your application on Arm, you build with a community. You build with an ecosystem with the open source community. These are just a few numbers. There are many, many open source projects created by Arm, but also created by the community where we contribute. And talking about open source contribution and talking about AI, there are certainly many frameworks out there that are capable to run AI workloads on mobile phones. And this is just a few examples of few frameworks, actually, where you can run your AI application on mobile. What's the beauty of this? Every time I show this slide, I say, this is great. This is great because each framework, whether it is LiteRT, ExecuTorch, Tencent Huion, ONNX Runtime, MNN, Llama.cpp, each one brings their own strength. Each one has a particular feature that makes the framework relevant for a particular use case. Some of them are great, for instance, for running particular large language models. For instance, LiteRT is great for the Gemma performance, just to give an example. Or ExecuTorch is great for running Llama models. Or the ONNX Runtime may be for the Phi models as well. Or others might be better for running large language models, or others might be great to run convolutional-based neural networks. Many solutions, but how we can make sure that actually our developers can have the best performance on ARM, because there are so many solutions out there, right? And we don't want our developers to suffer from performance on the CPU. And this is actually our secret sauce. Actually, one of the two secret sources I'm going to mention today. This is the Arm KleidiAI library, something that we have started developing last year with a promise to accelerate the AI computation everywhere in a very simple way. This is a library that contains the most critical routines optimized for the Arm CPU. And it is already integrated in all the frameworks we have seen earlier in the previous slide. And this is the vision. So we have our application developer, and they have to decide which framework to use. And they have many options, as you have seen before, right? Once they have decided, these must run well on ARM. How? Through the Arm KleidiAI library. So KleidiAI is already integrating many of these frameworks to make your life easier. As I said, I'm a developer, but I also want the flexibility to opt for different frameworks depending on the use case I'm targeting. And the fact that I have a library that is already integrating all these libraries, it will make my life easier when I talk about performance, because I always want better performance. These are some of the features of the Arm KleidiAI library. It's a lightweight library which contains critical operations for neural networks. There are no dependencies on other libraries. There is no memory allocation, no threading mechanism. There are what we call it the microkernels. It's written in C for having a compatibility with as many frameworks as possible, because when we talk about mobile and edge deployment, there is also the fact that some frameworks are written in C and not in C++. There's actually, that is the reason why we decided to develop a library in C. It's a library not just for generative AI, but certainly most of the optimized routines are for accelerating generative AI. But these optimizations are also applicable for classic machine learning algorithms or also for convolutional-based neural networks. Let's go back to the use cases. I started with some use cases at the very beginning. Now I'm going to highlight two use cases that will help me to understand why we have developed a technology that I'm going to announce later. AudioGen, as we have seen, we have an input text that describes the type of audio I want. This has been announced in May 25, although we have promoted at MWC, but officially the model was publicly available in May 25, also with a tutorial. If you want to run it on your laptop or your mobile phone, you can just follow a tutorial. If I recall correctly, there are just 3 steps. CMake, ... make, blah, run. I think there are just 3 steps for running this example. I love it. Why do we want AudioGen on mobile phone? Or at the edge? Because if you're a music producer, or you are an artist, you know this is actually an iterative process. It's not like I text what I want, and for sure at the first attempt, I'm going to get the best music in the world. And we know that. You have to experiment. You have to try it. And with generative AI, this is actually great, because with the same text, every time you can always have different audio samples. This is the reason why it's called generative AI. It's not like I have a text and I always have the same audio sample. By running locally, this means that I can basically remove all the cloud instances, or I don't need to send infinite requests to create my music. So I can be simply on my machine, on my device, to experiment and try as many times as I want. It saves time, but also it saves and cost as well. This is the pipeline used for AudioGen. It's not super complicated, but there are at least 3 models, and there are also intermediate steps for, in a blue box. The intermediate steps is what I call the mixed pipeline, because some of these are models, the violet ones, but the blue ones are actually the computation that happens in the middle. And the fact that we're running on a CPU, this makes everything a lot easier. I have also reported the data types for the models, because here we're talking about audio. Quality is everything. FP32, Int8, FP16. We need a bit of flexibility. Another use case is not new, but actually we think in a different way, is the smart speaker. If we think about the smart speaker, in the past was simply one aspect of the smart speaker was running locally. Most of the computation was happening in the cloud. Now, because of generative AI, these can run fully locally. It can be fully private. You don't necessarily need internet connection to control your devices at home. You can ask Orbit, for instance, this is just a name that we have given to the smart assistant, to dim the light to 50%, and also tell a bedtime story to your child. And your device can know the name of your child and can start telling the story without internet connection. What's the pipeline here? Well, there are mainly, excluding the wake-up word, okay, keyword spotting, what we usually say it, there are mainly 3 stages here. Speech to text, that you can use Whisper, and this can be done with different data types. The LLM part, and the text-to-speech part. All of these can run today on device, on mobile, on the Arm CPU. I don't think we can hear the audio.
And the speed of travel. Generally, it can take anywhere from several hours to several days for a spacecraft to reach orbit around the Earth.
So unfortunately, we only heard the last 10 seconds, but actually this was running everything on device without internet connection. And here, what I want to talk about is the SME2 technology. We have seen that there are many ways we can run AI. We have seen how flexible we need to be. We have different data types in our workloads. Therefore, Arm introduced SME2, a set of advanced CPU instructions for the ARMv9 architecture to boost the performance of AI workloads, image processing workloads, or computer vision workloads. Or what I usually say, if you have workloads where you have a lot of heavy matrix multiplication, this technology will help you a lot. This is built on top of the SVE2, the Scalable Vector Extension 2. This makes the, what you're going to see later, this will provide a lot of flexibility, in particular when you're going to write your code, in particular for future extensions. One key feature of the SME2 technology is the MOPA. And this is the key behind the level of performance you're going to see in the next few slides. MOPA is an instruction that performs the matrix auto-product accumulate to enable very efficient matrix multiplication. And if you're familiar with the dot product, the dot product returns a scalar value. The auto product instead returns a matrix. Therefore, if we put in the context of matrix multiplication, this is an example, okay? And an example of matrix multiply where the matrix multiplication is defined as the dot product between a specific row of the left-hand side matrix and a specific column, the right-hand side matrix. These can be decomposed in auto products. And this is behind all the optimizations that we have done already with the SME2 technology. By doing so, using this specific instruction, we managed to achieve very good performance, and you're going to see what level of performance in particular for generative AI workloads. But let's have a look at the MOPA instruction. In particular, what you have in this slide is the floating point matrix auto product accumulate. So there are 4 arguments for this, and is the instruction name. What we have is the destination register, which is a tile, is not a vector register. And we also have the input vectors together. That's it. By simply calling these several times, you perform the matrix multiplication. This instruction is provided for different data types. As I said, we need flexibility and versatility. So this is actually the beauty of this instruction. And these are the level of performance you're seeing today already. We're talking about more than 6 times better performance on key generative AI use cases. For instance, on Gemma 3, on Whisper, and also we have seen more than 3 times better performance with AudioGen through stable audio open small. To give a bit of context in the next few minutes, this means that, for instance, if you're using Gemma 3, it will enable the text summarization in just a few seconds. So you basically start seeing the text on the screen just a few seconds to summarize a 4-paragraph page. In case of AudioGen, it means that you have 11 seconds of audio in roughly 2 seconds. These are the other use cases. It's not just about AI. It's about camera, augmented reality, and multimodal AI, many, many others. So as I said, whatever use case you have, if you have a lot of heavy matrix multiplication routines, this technology will help you to improve the performance. And this is the announcement. This is already available on iOS, and it's coming soon to Android. And this is my recommendation to Android developers. If you are developing an AI application for Android smartphones, now is the time to look at what AI framework you're using and check whether you're using a framework with KleidiAI support. Because if this is the case, you won't need any change in your application. You're going to get for free this performance. And this is the conclusion of this presentation. So the first thing is about SME2 is absolutely the most versatile and future-ready platform. It provides the programmability that we need, the support for different data types, and also the performance that we need for achieving real-time performance for AI workloads, today and tomorrow. The other aspect, as I mentioned earlier, if you are an Android smartphone developer, please have a look at what AI framework you're using. Because if you're using one of these frameworks listed here, like LiteRT, MediaPipe, Alibaba MNN, Microsoft ONNX Runtime, you're good to go. No code changes on your end. You're going to get the performance that you need on SME2 for free. Many other frameworks will come later this year. And I think that's it. So many thanks for attending this presentation. I think we have probably 2 minutes for questions.
Thank you very much. I see you haven't used the app. Do you have any ad hoc questions for our presenter? Oh, yeah, there's one. 1 second, please.
OK, thank you very much for your talk. Very interesting. Is there also, because you mentioned performance increasing and like increased performance and stuff, is there also power consumption, better power consumption, better battery usage out of models that integrate into KleidiAI?
So about power, we don't have the data here. I haven't reported the slide. This is more about performance. But later this year, you're going to have more information also about that. Thank you.
Any other questions? There's one.
So you mentioned that it's already available on iOS. Is that because those instruction set didn't need any hardware changes on Apple's side? Or is this because it's primarily, it only needs a change in the kernel? Or?
No. I mean, if you have an iOS-based device, and you have an ARM-based device, basically you're going to get the SME2 acceleration. Of course, to get the SME2 acceleration, you need the library with the SME2 optimizations. Okay? So if you're using, for instance, LiteRT on an iOS-based devices, you're going to get these for free.
All right. Are there any? Oh, there's another one, and that's, I guess, the last one. Okay.
Perfect.
You mentioned 6 times performance increase when doing inference on the CPU. But my question is, as far as I know, ARM also designs GPUs. Why not do it in the GPU in the first place, which is kind of the unit that is already faster in matrix multiplications to begin with?
Okay, very interesting question. So I don't have data for the GPU. Of course, this is part of the story. This is about the CPU story, right? But of course, it depends. It's not just about the name CPU, GPU. What it matters is actually how many multiply accumulates operation you can deliver per clock, per core, right? So in this particular case, we don't have any reference for GPU. It's mainly about the CPU. So unfortunately, I don't have data. But as you can see, the performance are quite compelling. In particular, we're talking about the geometry performance and the Q1 performance.
Thank you.
Thanks.
All right. Thank you very much, everyone, for attending the session. Please, an applause for our speaker.
Thanks a lot.
Anything else?
No, thanks a lot again. In case you want to connect, I will be here today. So in case you also want to see the demo on mobile phone, I have the phone with me. So it's going to be a pleasure, actually, to talk a bit more about this.